Hello children, welcome to our YouTube channel AKN Sprint Education. Myself Naveen, I am the maths mentor, and today's session let us discuss about the glance introduction about real numbers. Okay, in this chapter let us see about real numbers and about decimals, and then about L.C.M and H.C.F and Euclid division lemma, also about logarithms. Now first of all, let us see what do you mean by real numbers. The union of rational and irrational numbers are called real numbers. Now what do you mean by rational number? A rational number is a number that can be in the form of p by q, where p and q are integers and q is not equal to 0. Example 2, 3 by 4. It is represented by q. Now what do you mean by irrational number? The numbers which cannot be expressed in the form of p by q are irrational numbers. Example root 2, root 3, root 5, root 11, root 21, comma, pi. Now let us see what do you mean by decimal numbers. In algebra, decimals are one of the types of numbers which has a whole number and the fractional part separated by a decimal point. The dot present between the whole number and fraction part is called decimal point. Example 34.5 is a decimal number. Here 34 is a whole number part and 5 is the fractional part. The dot is called decimal point. Right? Now let us see types of decimal numbers. We have two types of decimal numbers. The one is terminating decimal. A terminating decimal is a decimal that ends, that is, it has a finite number of digits. For a fraction in a decimal form, while performing division, after a certain number of steps, we get the remainder 0. The quotient obtained as decimal is called the terminating decimal. Example 3 by 8, it gives 0.375, has 3 digits after decimal point. 5 by 4, nothing but 1.25 has 2 digits after decimal point. Hence 0.375 and 1.25 are terminating decimals. Now the second one is non-terminating recurring decimal. While expressing a fraction in the decimal form, when we perform division, we get some remainder. If the division process does not end, that is, we do not get the remainder equal to 0, then such decimal is known as non-terminating decimal. In some cases, a digit or a block of digits repeat itself in the decimal part. Then the decimal is non-terminating recurring decimal. Example 1.666 and so on, 0.141414 and so on. Now let us see L.C.M and H.C.F methods. We have two types of methods. First one is prime factorization method. Find L.C.M and H.C.F of the following integers by applying prime factorization method. If you see the numbers here, 12, 15, 21, 2 6 are 12, 2 3 are 6, 3 1 are 3. 15, 3 5 are 15, 5 1 are 5. 21, 3 7 are 21, 7 1 are 7. 12 we can write as 2 into 2 into 3. 2 is repeating 2 times, 2 to the power of 2. 3 is repeating 1 time, 3 to the power of 1. 15 we can express as 3 into 5, 3 to the power of 1 into 5 to the power of 1. 21 we can express as 3 into 7, 3 to the power of 1 into 7 to the power of 1. How to find HCF? HCF is nothing but product of smallest power of each common prime factor. As we have 3 is the common prime factor, so HCF is 3. LCM means product of greatest power of each factor, each prime factor. So 2 square into 3 power 1 into 5 power 1 into 7 power 1. 4 into 3 into 5 into 7, that is equal to 420. Now second method is long division method. As we know, 12 1 ja 12, 16 minus 12 4. Now that 12 becomes divisor, dividend now. 4 3 ja 12, we got 0. At where we got 0? At 4, right? So HCF equal to 4. And long division method LCM, 2 12 ja 24, 2 18 ja 36, 2 6 ja 12, 2 9 ja 18, 3 2 ja 6, 3 3 ja 9. So LCM equal to 2 into 2 into 3 into 2 into 3. That implies 72. So these are the two methods of finding LCM and HCF. Now coming to Euclid's division lemma, EDL. So what is EDL? It states for any two positive integers a and b, there exists a positive integer q and r such that a equal to bq plus r, where r is lies between 0 and b. For example, if we consider two numbers 17 and 3, as a is 17 and b is 3, so 17 we can write as 3 into 5 plus 2. 3 5 is 15 plus 2, 17. Here quotient is 5 and remainder is 2. Q is called quotient and R is called remainder. That is EDL. Now coming to logarithms. What do you mean by logarithm? If there are three quantities indicated by say a, x and n, then they are related as follows. If a power x equal to n, where n is greater than 0, a is greater than 0 and a must be not equal to 1, then x is said to be logarithm of number n to the base a. Log n to the base a equal to x. Now properties of logarithms. The first one is addition property. Log xy to the base a equal to log x to the base a plus log y to the base a. Second one, subtraction property. Log x by y to the base a equal to log x to the base a minus log y to the base a. Next, multiplication property. Log x to the power of n to the base a equal to n into log x to the base a. Inverse property. Log x to the base a equal to 1 by log a to the base x. Division property. Log x to the base a, I can write as log x to the base b by log a to the base b. Applications of division property. Log x to the base x equal to 1. If no base value is mentioned in a log, then it is logarithm to the base 10, which is also known as common logarithm. Now types of logarithms. A logarithm with base 10 is called common logarithm. That is, our calculator assumes base 10. Log x to the base 10 equal to log x, normally written without the base. Now coming to logarithm with base e is called natural logarithm. We usually written this as ln. Log x to the base e is nothing but ln to the ln x. Now let us see what are the characteristics and mantissa. The integral part of the logarithm of a number is called characteristic. The positive decimal part is called mantissa. See, the most important note is characteristics may be positive, negative or 0, but mantissa is always positive. Example, log n equal to 3.64741, we can write as 3 plus 0.64741. Then characteristic is 3 and mantissa is 0.64741. Right? This is about our introduction to logarithm, children. I hope this about this chapter key concept you very crystal clear to you. Thank you for watching my channel. Don't forget to hit subscribe button, like it and share it with your friends, children. Thank you.